All right, cool guys. So today we're going to be talking about hashes and the internet. So does anyone know how just the internet works in general? Like when we visit a website like Reddit or YouTube.com, what exactly is happening when we do this? Anyone have any idea? Go ahead.
Our browser is sending an HTTP request to a server somewhere in Iceland or wherever, and then it's serving the page back, depending on what the address is in. And then
Exactly. That's the whole thing that happens. It's a request and response cycle. So when we put something into our browser's header here, and then we get all this stuff back, what happens is that we actually just send the request to youtube.com. If we open up what's called our developer tools and we check out the network tab and we reload this, these are all the GET requests that essentially we sent out, and then we have different status codes telling us whether the request was good. Status codes of 200 means that everything's okay. A 300 status code means that we're redirected somewhere. 400 is essentially some sort of error that was on our part as a person surfing the internet. And then 500 status codes are errors that occur on the server side. Let's say you put something that broke the server and doesn't know how to respond itself. It might give you a 500 error in that case. And that's more the programmer's fault or the person responsible for the website than it is their own fault. So if we see all these different things that we get back, what YouTube is sending us, this first one right here, this is the actual HTML response that we get back. And then all this stuff that's inside of here that's like an image or any other asset, like the script files, which are JavaScript files, will then continue to get loaded because now this document is the one making the request for all these other things that are out on the internet. So this like web animation, NextLight, min.js, that comes from the original request that we sent out to Google, or I'm sorry, to YouTube. So essentially, everything on the internet is hold on, do I have this? Am I recording? Yes, right? Yeah. Is a request response cycle. So how is this important to us? How can we as programmers take this information and kind of just use the information that another website gives us to just kind of play around with new data, new stuff? Does anyone have any idea what the common term is for like an interface that they give us to be able to get information from third-party websites? An API. Yep. Cool. So an API is essentially, what it stands for is Application Programming Interface. On the web is a very specific type of API, which is just on the web, but there's really APIs at every level. Like your phone has an API that you could hook into. It's the interface that we have to hook into different methods that the phone might have, like get location services or something like that. So on the internet, most APIs that come to us are a JSON object or JavaScript object notation, which is just a really big hash. That's all it is. So every time we make a request to something, we're essentially, to an API at least, we're just getting a big hash back. A very common one is github.com/users. And what does this look like to you guys? An array of hashes, exactly. So even GitHub's front page, if we go to just github.com, this is usually, well, I'm not signed in, but this is usually them just getting that information, and usually like all this stuff that gets displayed is coming from an API, and they use some sort of front end framework to kind of put all that dynamic content that's in there. So like all my repositories are going to come from users/0on/repositories, some endpoint that's going to generate these repositories that are right here. All the stuff that we see on a page that's being built is information that essentially we're getting as programmers and then loading them dynamically to have different content for every different user that logs in. So This is just a regular API request to github.com/users with just API appended in front of it. Mojumbo, do you guys know who this is? It's one of the co-founders of GitHub. So it's obvious that his ID would probably be 1. He probably was the first one that created an account on there. So yeah, and then we could take this information in Ruby or in JavaScript or in anything, and then we could parse it, turn it from a string. Even though this looks like a hash, really, if we look at it raw, this is really just one big long string. Right here is formatted real pretty, but sometimes you're gonna see that the format is just gonna be literally just a big long string that's just not formatted with no line breaks, no nothing. However, because of the rules of hashes and JSON objects, it knows that if I see this, and then I see this, and I see this, with something that continues to follow it, it's a regular hash. We don't need those line breaks. We don't need those spaces. We just need the rules of, okay, comma, there's something else, comma, there's something else. So we can really get rid of most of the white space and just send a really long string without it being parsed. There's other websites that also offer us access to their data. For instance, Reddit is another one that I'm sometimes hesitant to go to because the front page can be a little scary. So, yeah, see, there we go. Oh, Jesus. So, yeah. So we can get, this is essentially all the information that's on the front page of Reddit right now. So if we went to reddit.com, what did that say? Something about people who can fall asleep. There it is. All right. So they just grabbed that information. All right, it's a little mature content, but so they're just grabbing that information, right? And it's coming from their API and displaying it on the front end somehow. And we could actually use that same information ourselves, and we could make a clone in our liking of Reddit if we wanted to. Like, we could change the way that it looks, we could change the CSS, and we can just have, like, I don't know, Reddit or something, whatever, right? So essentially, that's how the internet works. It's a bunch of hashes that are out there that we're getting back. There's other different types of data in for APIs. We can get like XML data also, which is starting to become a little less popular. But for the most part, we're going to be dealing with just JSON, which we're going to turn into hashes. So a JSON object looks almost identical to a hash if we kind of just look at the way that it's set up. Does anybody have any questions on that part so far? Cool. Awesome. So what we're going to do today is we are going to actually build a little CLI app from the Google Books API, and then we're going to get some user input and try to just get different books, like different titles, authors from the Google Books API, which is just an open source API that we can use. And I think I've got the...
I have a question.
What's up?
So is like every website have an accessible API, or is it like
No.
so
No.
I can't go into like Capital One API and get all?
No. There might be. Like, you have to search, and there's also paid APIs. Like, there's a lot of, especially like in finance, you have APIs that, sometimes they can cost you $1,000, $2,000, $100,000 a month just to use their data. So there's a lot of different APIs out there, and all it is it's really just data for you to use to be able to build your web application. If you are, in the banking industry and need to get real-time stock information, then you want to use a professional API that's going to give it to you immediately. There's open source stuff out there that exists. There's one called like Alpha Vantage that I think is free for like a bunch of requests. But if you're if you're playing with people's money and you're trying to create trades and do all this sort of thing, it might not be the best choice. You're going to want to go with a professional API. So yeah, it really depends on the service. There's a lot of APIs just to joke around and play with. Later on today, we're going to be playing with the Star Wars API. where you can give it like different character names or whatever, and it just gives you back a bunch of information about those characters or episodes or whatever you call it. I'm not a big Star Wars guy, more of Star Trek, but whatever. Cool. Any other questions?
So when like I hear about like Mark Zuckerberg like selling like data, or is he selling APIs or?
That's a good question. I mean, it could be. It could be. But I think it's more like people get access to like
Just Facebook.
just your Facebook information in general, like your likes, your whoever you're following, all that sort of stuff, and then you could like target ads specifically to like a particular user group. I mean, Facebook knows so much. They know what religion you are. They know what political party you're affiliated with.
It always pops up on every single ad.
Yeah.
Well, there's that, and then you have remarketing, which is part of your cookies that follows you around. And if you visited any website, you're gonna see that it's gonna follow you from site to site to site. So those cookies, sometimes they have a cookie on one site that belongs to like this big ad network. So even though you go on a completely different site, if they're in that same ad network, they'll have all that same information. Like, oh, you visited this site, and they start building like a pretty detailed picture of what you like to search for.
Can you lock down an API by your specific date, or once you obtain an API, it's just like real-time data coming in?
Lock it down. I mean, you as a developer are going to be able to give as much or as little access as you want when we start creating APIs, which is going to happen in Mod 3. So you can lock it down as much as you want and only give access to specific areas of your data, or you can just leave it completely wide open to the world so they can take all the, so they can have access to all the data that you have in your database. And all this stuff is stuff that like this all ties in, because this is all stuff that we're going to be doing when we start saving our own data into database as users. What were we doing the other day? Whatever the model was it teachers and students? Yeah. For some reason, I thought it was like pizza and party or something. Thinking of another class. So, yeah, like teachers and classes, like you're gonna have all that data now that you're gonna be able to give to somebody as a hash on the internet for them to use if you wanted to, or you could just give it to yourself to use, so you can have a front-end application that you're going to be able to get the information from. So while it seems like this CLI stuff that we're doing is not super like relevant to web application, it's actually like the very beginning of building towards something cool and like useful that we can use further down the line. So like I mentioned, we're going to be using the Google Books API. And this is cool because it just gives us like a query that we can search for. Like it's got Q equals our query. So we can search for like Ruby programming, and we should get back a list of books and volumes with like Ruby program information. So what I want to do now is I want to create a little application to kind of just use this free API that's available to us to just play around and see how we can implement that into our projects or apps for later on down the week. So the first thing I'm going to do is I'm going to come to my terminal, and let me blow this up for you guys. Cool guy, that's right. Desktop. So I'm just creating a new file called googlebooks.rb, and then I'm going to open that up in my code editor. Bam, dope. Okay, so actually, let me also open up my little terminal down here. You know where the lights are?
Yeah.
It's a hike. Yeah, oh, that's dark. I could change the background color too, or if you guys like it, I mean, I could leave it this way with the lights.
You have the weather in your terminal?
Huh? I'm pulling that from somebody's website. So it's a curl request that essentially like just prints stuff out to your terminal. And all I did was like I customized my profile for when my computer starts up, and that's why I got all this like cool little stuff here, and like all these little shortcuts. Like when I git clone, I could just type in GCL instead of git clone.
You can customize all that.
Yeah, you can customize all that sort of stuff, and that the weather looks, huh?
Can you actually bring the screen down? I just want to see the website that you went to with the Google Books.
This guy? All right, cool. So, let's go back over here. How does this look? How's my text? Cool. Guess want it a little bigger, or is that, you guys are good? Okay, so how do we get this information from different websites? A gem. There's a bunch of different gems that we could use with Ruby to get website data. Does anyone know any gems in particular that exist out there? I know some of you guys have been playing with APIs already.
HTTP Party?
HTTP Party, yes. That one's super popular. I think it's only because of the name though, HTTP Party. There's another one called REST Client, and there's a ton more out there that exist. Today I'm going to be using REST Client. HTTP Party is definitely another option that you guys can use. I just know the documentation a little better than I do with HTTP Party. It's a mouthful too. That's why I can't deal with that. So what we're going to do is we're going to look at the documentation for REST Client for Ruby. And here it is in GitHub. And this is the Ruby gems file. Does everybody know what a gem is by now too? That's like a kind of very important thing to know. If we don't have our heads fully wrapped around that, I'd like to like just go over it really briefly. Or do we all feel good about? If we don't, it's okay. Just let me know and.
Just go over it.
Okay. Perfect. So, a gem is essentially just a little bundled piece of code that somebody else wrote that you can use. And you guys can write gems also that do like very particular things, like very specific stuff. So the way that we install gems is you could just literally from your command line type gem install whatever, and it knows to look into rubygems.org, and it searches all 341,363,136 gems that exist. So this is all open source stuff that people have just written and just put out there for us to use. REST client being one of them. So if I type in REST client, okay, here it is. So somebody just wrote this little piece of code. When we do gem install whatever, it gets installed into our machine, and then we could use it by doing require whatever. Just like with pry, we require pry. We had to install it first. Pry is just a Ruby gem, and there are hundreds of them. Even Ruby on Rails, the Rails framework, is essentially a gem. Yep. So here is the gem information for REST client. It has 135 million downloads, 4,832 stars on GitHub, and it's telling you how to install it. Gem install REST client. If you guys don't have it, then you want to copy this and run that in your Jesus. No, let's go over here. And run that in your terminal. I have it, so it should go fairly quickly. I might have an older version.
That's like the library?
That's like a library, essentially, but it's a lot of times it's smaller than the library itself. But yeah, essentially it's extra code that allows us, it gives us more functionality. Like somebody else wrote like a method, like let's say for something more trivial, like cats. Like you created a cats class, and a cat has all these things, and you wanted to use a cat object in your file. You could literally, and you create a Ruby gem called cat, you could literally do gem install cats and then use all those methods by just requiring cats, and then you could do like cats.new. So right, so you would say cat1 equals cats.new, and then whatever kind of initialization things we have, and then you could just do like cat dot or cat1 dot meow. All right, and then that will do something, or whatever it is that somebody decided to do with this cats class and whatever methods it might have. So that's the same thing. Like, it's really that simple when we use something like HTTP or REST client. It's literally us just requiring this REST client thing, and then somebody wrote the code that gave us these methods that we can now use. So what we're going to do is we're just going to require REST client. And if we look at the doc, you could put it in a gem file if you want. If you do gem file, yeah, then you would require in your environment, or you would require it right in the file that you needed specifically. So the gem file, essentially all it does is it tells, like, if you have a gem file, it doesn't get installed onto your system. It just gets installed in that directory. When we do gem install whatever, it's installed in your system now, so you don't have to continuously reinstall it. Let's go to GitHub. And let's look at the documentation for this. Now, if it's a popular Ruby gem, it probably has a ton of great documentation. So here are the requirements. It tells you we need Ruby 2.0 and newer. Tells us how to upgrade, and then usage. This is what we care about. So, bam, right here it tells us exactly what we need. And we have a get and we have a post request. So a get request essentially is us asking information up the server. A post would be us sending information to change something on the server. And there's 7 different methods that we can use, but the internet really only knows get and post. We kind of work around that, and we'll see that later when we get to mod 2. What the other 7 methods are, but essentially we have a method to 2 methods to edit, 1 method to delete, and then we got the get and the post request. So cool. So we're gonna drop that right in here. So again, we're just requiring REST client, and then we can do REST client.get, and we pass in the URL and headers. The headers is not required. But if you have to do some sort of special authorization or something to a different website, this is where it would go. You could say like authorization bearer, like if you're using a token, and then you would have like something crazy like that. But we don't need that. The Google Books API is open, so we can just use the URL here. And in our case, the URL was, nope. Dang it. This guy. Oh. Okay, and our query, what did we do before? Ruby programming. Okay, so we don't even need to do this from a file, but we already know how to use files. We can literally just spin up an IRB session here and run these 2 lines, and then we should get a response from this REST client action. But we're gonna do it from up here just because it's a little easier. We could type it out and we could save our information. Control C, no, exit. So another thing that we might want to do is require pry, right? So we can play around and stop execution. And let's just run this and see what happens. So to run, oh, I'm not on my desktop. To run this, we just write Ruby Google Yeah, books.rb. Okay, so we're at the pry, and nothing happened. Why? Yeah, we didn't save the response of this guy right here. So if we just do response equals that guy, there's a response. So I can just type in response. And that's what it is. If we look at the class, it's probably going to be something similar. So this is just a special class, like somebody creating a cat class or somebody creating a house class, whatever. So response.class is of type REST client, and it's namespace response. Okay, we could also see all the methods that we have available to us with that response. And we've got body, description, return, login. We probably have a headers, cookies that you guys are interested in. So all these things are in the response, and now we can actually just pin that onto the response itself and get some information back. So we can do like response at headers to get back like the status code and all that good stuff. So here it is. It's got the date, how long to cache this for, the type of content that we're getting back, the encoding that it is. It's just UTF-8. That's just the characters that we're using, and all this other cool stuff that we get in here. And the response should have a status, but I don't know where it is there. Cool. We could also get the body. And this is the body that we get back from that response. All right, and this looks like this might be some JSON data or a hash. So how do we make this stuff look pretty? What we can do with this response is Ruby has a built-in gem or library called JSON, and it takes that response and it parses it for us, and it makes it look pretty. So what we're going to do here is we're going to say response equals restclient.get. Save that here, and then we want to look for the JSON. So this is built in. So you need to require JSON, and then the way that you parse it is by just calling JSON.parse, then you pass in whatever that hash is. Okay, so let's just copy this bad boy. Okay, and then we're going to say my response. Actually, yeah, why not? No, it's JSON.parse. Let's exit out of here. Run that again. Let's check out my. So this is what we have now. We have a response, total items, and as you guys can see, something here is an array. We also have a hash in here. So REST client just parsed whatever the response was. So that's essentially the body of the information. And parsing is something that we're gonna have to do continuously. It's taking that long string that we get, and then it's turning it into something that we can use, like a hash. Later on in JavaScript, we're gonna parse it. We're gonna parse JSON so we can turn it into a JavaScript actual object. And all it is it's taking whatever came back from this and turning it into a big hash for us. Okay, and if we scroll down here, you're gonna see that it's an enormous hash that we're gonna be able to get information out of. Now, when we have a hash this big, it's a little difficult knowing exactly what we want. So what's a good method on a hash that we can use just to get like all the top level keys so we can kind of see what we can get in and out of from that hash. Anybody have any suggestions?
Dot keys.
What is it?
My response dot keys.
Yeah. So we have kind, total items, and items. So those are the keys to those hashes that we have. All right. So we could do my response and check out each one of these and see what we want. So now what I said we wanted earlier was to get a list of books and like print out their titles, their authors, and all that stuff, and ask for user input. So what I want to do is just get a list of these books now and their titles. So let's start just picking through all these and check out what's in kind. Kind only has a string called books and volumes, so that's not what we need. Total items. This just has a total number. So this isn't what we need either. What we want is a hash of all the items that came back, so I'm guessing it's probably just the last one that we have here, which is just items. All right, cool. So now we can see it's an array because we have the little opening bracket. So now we have an array of book items. All right, so how do we feel about this so far? Cool? The same thing we did a minute ago with keys, we can do the same thing for this guy now. So, because this is an array of hashes too, right? We're going to do items. We're going to get the first one. So we want the first hash, and then we're going to do that keys on it, just so we could know what the keys are for the most part that come in each one of these hashes. So each individual item, each book, has a kind, an ID, an e-tag, a self-link, volume info, sale info, and all this other stuff. So if we wanted to get the title, what might be a good first key to look at to see if the title is in there? I would think volume info would probably be a good one. Search info. Let's try volume info first. So we're going to grab the same guy here, my response dot whatever.
Basically navigating through this API.
Yep. Volume info. What did I do wrong here? Yeah, sorry. Cool. And that's actually exactly what we need. The first one is called, it's got the title, it's got a subtitle, it's got authors, publish date, description. So that's got all the information that we want. So now we know that this is how we get all the information for each individual book. Okay, so we've got my response, and so this is for the first one, right? Because remember, it was an array. So if we want all books, we have to set that equal to my response.items, right? So then from the books, we're going to have to get the volume info individually. All right, so we're going to have to iterate over this and get each individual book and then pin on volume info for all those. How do we feel about that? Because I kind of put a lot of steps in just one go there.
You can say it again.
So the first thing we did was we got my response, which was the parse response that turned it into a big hash for us, right? So that's just a big hash of books. That hash had different keys, and one of those keys had an array of the rest of the books that were in there. Go ahead.
Yeah, but was that just for what you searched for with the Ruby programming, or is that all books that are in this API?
That's just for the Ruby programming, what I searched for. And later we're going to change this up so we can put different strings in there.
The HTTP request, that's just for what you searched for?
Yes.
Not
Yep.
the bulk of that.
Mm-hmm. Yep. So we had different keys. One of the keys had an array of books, and that key was called items. So I saved from that hash only the array of books, and I called it all books. So this is an array, and we know that to get through an array, we have to iterate so that we can do stuff with it. So what's a good way to iterate through this? Just like print out the titles. Anybody? Okay. What should go in here? Book, because there's an array of books. And let's say we just want to print out the book's title. How would we do that? It's a hash, right? Yeah. Okay. And over here, we want to do puts. And this is just going to give us a nice little separator for all the books. So this line, don't worry about it. Like I said, this just separates it. It's like me drawing 60 equal signs underneath each book title. So when we run this again, we're going to go through the books array, and then we're only going to print out just the title of each book. Cool, and if we scroll up, that did not work. So we messed something up. And if we go back to the book,
It's because it's in volume info now.
was it in volume info?
Yeah.
Okay, so then we need another key in front of it. Cool. So let's try it again. Let's see what happens. There we go. So it had another key with more information, which was the information of the book. So if we look back at the object, this was the book, and then it had a bunch of different keys: kind, ID, e-tag, self-link, volume info, and inside of volume info was where we had title, subtitle, authors, and all that good stuff. All right, so we've printed out the volume info. How would we print out like the authors for this now too? Okay, and to make this a little prettier, we're just gonna do like authors plus that, and then we're gonna do, oh, I'm sorry, titles, yeah. Be a little dyslexic sometimes. Authors. And did you guys see that authors was a array? Okay, so that means there could be more than one author. So in this case, we have two authors, and if there was one, it would be an array with just one, right? So if I do this, it's gonna try to print out the array, and it might just say like object or something like that. So how can we turn this array into a string? Join, perfect. I was expecting someone to say iterate again, but if we just want a string of this, we can just join this array and we'll separate them by like a little pipe. Okay, so if we have 3 items, it's just gonna be now a string with 3 separate little pipes inside of it. Cool. So, oh. I didn't say this. But we also got undefined method join for nil class. Can anybody tell me why that happened? I'm gonna run this again so you guys can see it.
It's not one of the methods that you could run.
Oh, is it because it's a hash and not an array?
It isn't. I mean, it isn't.
So what's happening here is we're getting data back, but we're getting some data without an author's array at all, probably without even an author's key. So if we look at hashes, let's go to IRB, and I create a hash, and I do A equals A, well, let's just do symbols. And then I do A A, we're going to get hello. If I do A, B, we're going to get goodbye. But if I do A, beef to, in the spirit of Ballasta, we're going to get nil. So it's a key that doesn't exist, or it's just something that doesn't exist. So authors, this key author does not exist in this hash, so we're getting back nil. Okay, so that's what's happening there. So what else can we do to just say, hey, if this doesn't exist, let's just ignore it?
Yeah, you just said like, isn't there something that you can say like, add on to that like if not nil or something?
Yes, yep, cool. So if, and you don't even have to say not nil, you could just do this thing again. Because this will either return nil or something else. If it's something else, that means it's true. If it's nil, that means it's false. All right? Or if we want to do it in a more typical if statement, we could just do if this guy. Okay, and if you want to be really explicit, you could do not equal to nil. Okay? But we don't need to do that because it's either going to be nil or not. And if it's nil, that means it's false. So we could avoid that extra little bit of code. So now we're saying if this exists, if this key is out there, then we want to put the author and then we want to join it. So if we exit and we run that again and save also, very important to do. Oh no, not IRB. Cool, so now we made it. And we got some have authors, and there will be some with no authored somewhere. And it looks like Google Books paginates like the results somehow because it stops. It's at like 1,600 books, right? This one doesn't have an author. I felt like there were more. Anyway, cool. How do we feel about this so far? Do we have any questions on this?
So basically, you're just running over this giant hash, just returning values.
Yeah, and one of those keys in that hash is an array of books that we're going to use. And then we're going to iterate through that array of books. So it seems complicated now, but you're going to get really used to this. Maybe it doesn't seem complicated, I don't know. But really, if you think about it, that's simply we're getting back a humongous hash. Somewhere in that hash is a key that's got an array of all the info that we want. All we have to do is figure out where it is. And the way we do that is just by using that .keys method to see what the top level keys are and then inspecting each layer at a time and seeing what's in there. So it's not, it really isn't that complicated. You just have to be willing to get in there and just get into the nitty gritty and just play around and see what you get back. And I would say that's like 99% of programming. It's just trying it. I feel like a lot of times like we code stuff and we don't want to try it until we're done with it. No, you got to try it like right away. Does this put out a hello world statement? Yeah, great. Move on to the next line.
And I'm assuming we have to be like this whole request to get access to this API. Like we have, in order to use this program, it has to be connected to the internet. Like this isn't being downloaded into our system.
Exactly. Yeah. So that's, it's one of the great things about the modern computing world, and also one of the terrible things. Like a lot of your apps, programs, whatever, just won't work without the internet. Why? Because we're making this request to an API somewhere. So if you don't have internet access, like that database isn't saved on your personal phone. However, if it was, and you had all the stuff that we want access to, you would need so much storage on your phone that it would just make it impractical. And then every time something gets updated, you have to get this information back. So that's why we have these APIs, so that we can really just use the entire world without having to have like an enormous supercomputer with like infinite storage to be able to do these kinds of kind of trivial things if you think about it. Anybody have any other questions?
Can you explain why we have to use JSON parse?
JSON parse, yeah. So what we're getting back is a response object, all right? And that response object has a bunch of JSON in there. All right, and JSON is the stuff that we're just getting back from the internet. Like I said, when I showed you these before, like this is essentially what we get back. And what JSON.parse does is it turns this into a hash for us. All right, and this might have some other information at the top, like some header information. And let me put this on silent. And just different kind of information that we might want to use, but what we really want is just the body of that information. And what JSON.parse does is it abstracts a bunch of the nitty-gritty of like how we get that body, and it does that for us. And then it turns that body that's just a long string into a hash that we can use. So that's the reason why we need that.
So all the API, right, I'm sorry, is it always connected that form or different form there?
If it's an API, for the most part, there are some websites that are just going to send you back like HTML information. But even those websites with just HTML and JavaScript, like the JavaScript itself might make a API request somewhere else. So yeah, there's a lot of this stuff going on the internet, and I would say like it's probably like 80-90% of what's going on.
So is Ruby like the only programming language that can read APIs, or is like?
No. We're going to be doing this later with JavaScript. You can do it with Java. You can do it with Python. And they all have like their different gems or whatever that you can use. But essentially it's the same thing. We have a request. We have a response. We have to parse that response. And then we have to do something with it for us that's useful, whether it's printing stuff on the screen or essentially just printing stuff on the screen in a way that we want to print it. So right now we're printing stuff on the CLI. In the future, we're going to be making beautiful websites. So it's all going to come together. Cool. So now we were able to get the book's title, the authors. We fixed the case where there might not be any authors and it just won't print. But if there is an author key, then we actually print the authors and we separate them with a little pipe if there's more than one. Cool. So what if we wanted to make this a little more dynamic so that we can ask the user for input? What kind of subject are you interested in getting book information about? And using his response to generate something that is important to them. What's something that we can use? Cool. So we can say, this is a URL, right? We can say URL equals gets.chomp, right? And then we can get rid of this stuff and just put in URL. So let's prompt the user. Actually, it's just a user input, so we don't want just URL, because that would just search for like Ruby programming, not Google Books API. So I'm going to need to get that again. From here. And then how do I change our query to the user's input in the URL? Cool. So that should search for whatever the user got in here. So our program is going to run now. It's going to stop here when it gets to the gets.chomp. We're going to get that input. We're going to feed that into the URL by interpolating it, and now we're going to get a response from the client with whatever input that we put in there. So now this is looking a little more interactive, a little more dynamic. So we're going to exit, run this again. What book would you like to search for? Anybody? Books? Harry Potter. Cool. So we got all these books. We got Harry Potter, The Complete Collection by J.K. Rowling. Yeah. cool. So now we can get all this information about these books. And you could imagine like a book review website can get this information, put it on there, put like titles, blah, blah, blah. And then we could also get the reviews that you guys have written as like part of your domain. So a book has many reviews, right? So this is all gonna tie together. So I just want you to keep that in mind. This is all gonna coalesce.
The Bible? That's just weird.
What was it? Or?
Harry Potter and the Bible.
Nice. Cool. By Richard Abanez.
Harry Potter's
What's up?
How does the URL know to change the space to a plus?
Because when you put it in a URL, what it does is it changes it to like a %20 or whatever. It's just something that it does on its own. And it's the same thing in JavaScript. Like if you just throw a string in there, a space is really like this weird character. So it knows what it is. And then when you put it into your this guy, it'll know to change those strings into that %20 or whatever. Or those spaces, I should say. Cool. So what else can we do? You want to get like author input? Is that what you mean, or? Yeah, so you could imagine that we could have like but this one is only giving us like volumes and query. There might be another key here like I don't know, and oh shit, not there. And author Q equals, and then we would have more stuff here. I don't know if Google Books has this other. It's called a query parameter. So I'm not gonna try it. It might break something. I'd have to look at what they allow. But yeah, so we can kind of do these things here. We could have, now that we have this little bit built out, we might want to start thinking about like breaking this into smaller methods and just have like a get user input, right? So get user input, and that'll do this. So now we can do another method, get response. So the response needs an input here, right? So we might do something like, hold on, first let's, from server. And let's parse it too while we're there. Okay, and this, since we have this guy here, it takes an input, a URL, and then the response is this guy. So we're gonna have to send in the input from somewhere. So let's just create a parameter, call it input. All right, and there we are. So what we're doing now is we're abstracting this. Instead of having one big old like just method, and not even method, like it's just being ran line by line, we're breaking this down into different methods to make this code a little more readable and more reusable. So we also have all books.each do. So we have a way to get all the books. So def get all books. And this one needs a response, right? Or a, what can we put here? You know what? Let's dump this guy in here. And get all books is just gonna do this business here. And we're gonna call this like print book info instead of get all books. And this is gonna take books or all books as I called it down there. And I'm going to end this guy here. And we're going to call this guy, instead of get response from server, we're going to call it get all books. And all I'm doing is I'm making the method definitions kind of match what the methods are actually doing. All right, and we just refactored this code into a bunch of different little methods that we can now use down here at the bottom. So now if somebody else wanted to add more information, like instead of print get all books, we could do something like just get first book that shows up on the list, get last book, and we could just define like a new method, def get first result, that might use this guy to just give us the first result that the server returns. And so on. We could do like get last result, or whatever our heart desires. And then to end this here, we're just going to call get user input, which is going to give us the input, and then get all books gets the input. So we're just going to start calling these methods one at a time. So input equals get user input. The next method is get all books. So all books equals get all books, and this guy took in, this guy took in the user's input. And then we want to print,
Everything just builds up.
Yep. Print book info, and then this will actually show this. Print book info, and then this would be, what did this take? Print book info takes all books, so we just push in all books right here. Okay, and this is our program, and we could wrap this in another method called run, and then we could just call run, and it'll do all these things. Does that make sense to you guys? Any questions on that?
Can you see it?
Yeah.
Oh, no. We're actually.
Oh, gotcha. Yeah. Clear this. Any books suggestions?
Vampire Diaries.
What paradise?
Vampire.
Oh, vampire. Cool. So we've got all this stuff in here. And if we want to get crazy, we could throw this into a loop so the program doesn't end until somebody gives us an input of 1. Okay, so we can wrap this in a while loop, and we could say while input does not equal 1. We're going to do this.
It has to be upward, right?
Huh?
The while input has to be upward, right?
Yeah, right here. I'm going to make this equal to nil right now, just initializing it. And if we run this again, I'm actually going to get rid of the binding.pry because it's just going to keep running until we decide to change the input to a 1 instead of a title for the book. So, and if we want to be a little more specific with the people up here, we say or press 1 to, or enter 1 to exit. Okay, this will continue to run, and we continue searching for books. I'm going to search for Vampire Diaries again. Okay, and see, we got again, we got all the Vampire Diary stuff here, but then we also got the prompt again. What book would you like to search for, or enter one to exit? So we can search for Harry Potter again, and now we got a bunch of the Harry Potter stuff, and it's going to continue asking us what book we would like to search for until we press 1 and enter, and the program ended. Any questions?
So actually, is this kind of like the guidelines of the project? Do we have to stick to something in this realm?
You don't have to use an API if you don't want to. APIs make a project a little more interesting.